Hey, hello. Today I'm going to demonstrate our submission for a Solidity Bootcamp, a Solidity 101 Bootcamp. We made a Price is Right type Web3 game. Right now it's just in its first iteration, but we got everything kind of working at a reasonable level. So I'm going to go ahead and demo that real quick. We used Ethers for the JSON RPC provider. We used Wagmi for our wallet interactions and transactions. We deployed using Hardhat, and then we have some really basic Tailwind CSS just to kind of organize a few things. It's not at all ready. And then the whole thing is in an NX React mono-repo. So let me go ahead and show you real quick. Everything's already spun up. We're currently connected with, right here, it's called account 3. This is the Hardhat account 0. This is the deployer. So the deployer has the ability to come here and open up a game of The Price is Right. So we're going to say that they have a laptop that they want people to guess how much the laptop costs. The actual price of this is, we'll say 1,000, and then we have this password. So we're going to take these three values and we're going to use a Keccak 256 algorithm to hash this. Now the hash is what's going to get stored on the blockchain. That way nobody can see what the actual price is, because that would break the game, right? And then the only way that the game can be closed is if all three of these values match, the hash matches, and then that's revealed so that everybody can check and see that yes, everything was saved correctly. Nobody cheated here. The item name will be visible because the contestants need to know what they're betting on. I've disabled the game time just for this demonstration, because if not, we have to sit here and wait 10 minutes or whatever it is. So the deployer is going to go ahead and open up the game, and there we go. Now these other contestants can go ahead and enter the competition. But first, they need our ERC20, they need our Price is Right tokens. The ERC20 is deployed within the Price is Right smart contract. It automatically deploys it and uses it as payment for entry into the contest. So right now they're free. Account 4 is going to go ahead and get some of these. And then we will also switch to account 5, and they will also request some tokens. And then while this is going on, account 4 should be ready. We can see that they have 100 Price is Right tokens. So account 4 is going to go ahead and enter the contest. And I need to re-render to pull in the item name. That's not good. But so yeah, here we have a laptop. So they know that that's what we're bidding on. We give more information of, Apple, MacBook Pro, whatever, so they can guess. And let's say he thinks it's $800. It's going to go ahead and submit. It's going to ask to spend 10 Price is Right tokens. We're going to say yes. We're going to approve this transaction, and then, or we're going to approve the right to spend those tokens, and then we're going to approve the actual transaction. And we should see that he has now spent 10 Price of Right tokens to enter the contest. Cool. Now account 5 is going to go ahead and enter as well. And account 5 is a little smarter. So they're going to say 900. And same thing. Approve the Price is Right tokens, and then approve the transaction. And there we go. So now we have these utility functions down here, but one of them is going to be to get our contestants. This is going to randomly select, which we've used an Oracle for. It's going to randomly select 4 contestants from the contestant pool to go ahead and bid on this item. So they've already entered their bids, but we need to select random contestants just like in The Price is Right. So they say, come on down. So we need to be the account 3. So they're going to go ahead and do that. They're going to get contestants. He's going to go ahead and approve this. And then there we go. Now, of course, we only have 2 contestants, so they're the ones who are going to get selected. But the deployer can now come here and he can go ahead and close this up. Now, again, if he doesn't enter in, let's say he misspells something, which is unfortunate, but if it doesn't match the hashed value originally sent in, then this transaction is going to fail. And we can see that it failed because the revealed values do not match, right? The hash submitted for those 3 values don't match the hash that was stored on the blockchain. But if we go ahead and do the correct information, boom, And there we go. And this says that we have a winner because it's now taken those random contestants and it's checked who's closest, and then it awards them a ERC 721, our NFT, which is also deployed within the smart contract and is what we are calling a golden ticket. So they should have an NFT. There we go, right there. And this golden ticket is what's going to give them access to a mini game, we'll say, just like in The Price is Right, where the person who wins the first round goes on to play some kind of game, which is kind of going to be my next project for this, to kind of build on this project. Now I'm having trouble. Oh, and I forgot to host IPFS locally. Maybe that's why it's not working. But we do have metadata for this NFT, and that's why I have, again, these utility functions so that we can go ahead and see this. Yep, there it is right there. And this is the metadata associated with that NFT, and it's supposed to display this Price is Right golden ticket. So that is the final project very, very quickly in a nutshell. There's still a lot of work to be done, but everything here is up and running. So, yep, thank you very much, and I hope soon to be able to demonstrate some of the things that I've built on top of this. So have a good day.